Hello, everybody. Welcome to the skill on ellipses. So clearly it's not March 2014. I am shamelessly borrowing this from a web resource that I found. Anyway, today we're going to talk about ellipses. So you can think of them like circles that are just kind of squished. Okay. So the graph of an ellipse, sometimes you might call them an oval. And there are going to be some equation forms that you need to become familiar with. So first of all, notice that in our pictures, we have centers at the origin. So when you see the equation written in the first forms, that's a center at the origin. We have x squared over a squared plus y squared over b squared equals 1. That'll be the case when you see that the oval is longer than it is tall. Or I guess wider than it is tall, however you want to think of it. In other words, the x-axis is larger. Okay? And then the only thing that changes if we have a vertical ellipse is that the y direction is longer, which means that it's taller than it is wide. And notice how the equation changes. The a squared and b squared just switch places. Notice that the a squared value is always underneath the variable that is the longer length. Okay, so what that means is that a squared is always greater than b squared. Okay. So when you're looking at an equation and you're trying to determine whether or not it should be horizontal or vertical, look at the denominators and see which denominator is bigger. That bigger number, whatever variable it's under, is going to tell you which axis will be the longer axis. Okay, and we'll do practice with this momentarily. Now, as we saw with circles, not all ellipses are going to be centered at the origin. So if you look at these next equations, they kind of look like our circle equations, except we have denominators. These are going to be equations where the center is at h comma k. Okay. And same rules apply if it is pretend that the center is not at the origin, but the center is just somewhere else. If I drew a picture of this, notice that this a squared is underneath the x part. So that means that this will be one that's longer than it is tall. And in the second format, you'll see that the a squared is underneath the y variable, which means it would be tall and thin. Okay, so once again, the a squared must be greater than b squared. Okay? So on a horizontal ellipse, the major axis is along the x-axis, or x direction. We call the major axis the axis that is longer, so it is the longer axis. And the minor axis is going to be, let me use a different color here. Minor axis is going to be the shorter length, okay? And in this example, on the horizontal ellipse, the shorter axis would be along the y, or the minor axis would be along the y direction. Okay? And on a vertical ellipse, it's just going to be reversed. The major axis will be the one along the y-axis, or along the y direction, because it's not always going to be on the y-axis. And the shorter axis, the one on the vertical ellipse, will be the horizontal one, so along the x direction. Okay? All right. Our vertices are going to be the endpoints, so endpoints of the major axis. That's going to be in both situations here. And the co-vertices are going to be the endpoints of the minor axis. Okay, and that'll be in both situations. And we are not going to worry about foci. If you want to study this in more detail, maybe in college or in calculus or somewhere else, that is fine with me. But we are not going to study the foci here. Okay? All right, so I'm going to start with graphing some ellipses. So if we look at this first one, the first equation is already written in the form of an equation where we're at the origin. Okay, so we have a center at the origin. So I'm going to go ahead and plot that point now. And to determine whether the major axis is horizontal or vertical, I look for the larger denominator. And my larger denominator is this 16. Okay, and that's underneath the y, so I know it's going to be taller than it is wide. Now, this is my a squared value. But to plot it, I need to know the a. So I'm going to take the square root of both sides, and we get a equals plus or minus 4. And I have to have the plus or minus because what I'm going to do is I am going to go from that center, and I'm going to go up 4 to get a vertex, and I'm going to go down 4 to get the other vertex. Okay? And then to figure out the minor, so this was our major axis that I did, this 9 will give me my minor axis. So we know that 9 is equal to b squared. Take the square roots, and you get plus or minus 3 as our b values. Those b values tell us the minor axis, and since it's under the x, that means I go in the horizontal direction. So I'm going to go plus 3 and minus 3. And now that I have those 4 points, I'm going to do my darndest to connect them to make an ellipse. And I always do a terrible job at these. Pretend that looks like a nice ellipse, okay? All right, on the next one, for the next one, oh goodness, come on. For the next one, what we're going to do is we first have to observe that this equation does not equal 1. It has to equal 1, so I'm going to divide everything by 100. Okay? Now, 4 into 100 is the same as 1 over 25, so this becomes x squared over 25. 25 hundredths becomes 1/4, so y squared over 4. And 100 divided by 100 is 1. Okay, so now I can look at that, and I can see, once again, my center is still at the origin. Because if we look here, it just says x squared and y squared. There's no adding or subtracting on those. So now let's find the major axes. So major axis is going to be, so looking at this form of the equation, this time it will be the x-axis. So to find the vertices, I'm going to take, so a squared equals 25. I take the square root, and I get a equals plus or minus 5. Since we're going in the x direction this time, I'm going to go 5 to the right and 5 to the left to get my vertices. Now we're going to do the minor axis. The minor axis is the y-axis. Our smaller denominator was there. And the co-vertices, that's what they call them, the co-vertices are going to be, so we say b squared equals 4. Oops, I was about to skip a step. Take the square root of both sides, and we go plus or minus 2 in the y direction. So up 2 and down 2. And once we have those, we're going to create our ellipse. Do it just as best as we can. And that's how we make our ellipse. Okay? All right. When we look at these examples, we can see that here we're going to have centers that are different than the origins. So when we look at this first one, just like with our circles, what we're going to do is we're going to look at the opposite of this number, so positive 1, and the opposite of this number, negative 2. So we're going to have a center at 1, negative 2. So I want to make sure I plot that first. Okay. Now, looking at my larger number is underneath the y, so I know it's going to be vertically that I will have my major axis. So we know that a squared is 9. So that means that a is plus or minus 3. So I'm going to go up 3 and down 3 from that center I plotted. Minor axis, we look at this 4, it's along the x, so I'll be going horizontally. We know b squared is 4, so we take the square root, and b is plus or minus 2. So from that center I drew in orange, I'm going to go left 2 and right 2. And I end up with that ugly ellipse that I just drew. All right, for the next one, we're not equal to 1, so we have to divide by 36. Pretend there was a 1 in front of that. And since my first equation is just 1 over 36, I don't have to simplify any fractions. But 36 over 36, that just means I have a denominator of 1. I know it seems weird to write that, but in this case, I am going to keep it there. So now I use this form, and when I look at that, my center is going to be at -4, -3. So I'm going to plot -4, -3. Okay. Hopefully you get the patterns here by now. So my x variable has the bigger number. Square root of 36, we're going to go 6 right and 6 left. Barely on the graph. For my minor axis, I'm going to just go, so we just use the 1, we're going to go up 1 and down 1. So it's going to be a really skinny one this time. And there we go. All right, so what if I asked you to write the equation of one of these? Well, what I'm going to do is first look at my center, and here it's just 0, 0, so that just means x squared and then y squared equals 1. My larger number is clearly going to be along the y-axis, so I need to put, let's see, 1, 2, 3, 4, 5. We go 6 up, so 6 squared. For my minor axis, 1, 2, 3, so 3 squared. And when I simplify this, I get x squared over 9 plus y squared over 36 equals 1. Okay. For the next one, I have a center not at the origin. So I'm going to start it off like this. And my center is at 2, -3. So since x is positive 2, I write x minus 2. And then we had -3, so I'd have y plus 3. And now to write my denominators. Clearly our x-axis this time is the major axis. 1, 2, 3, 3 squared. Underneath the other one, it's just 1 squared. So we end up with x minus 2 squared over 9 plus y plus 3 squared over 1 equals 1. And that's going to be our equation. Okay. All right, we're not going to do any of these that do these things. So we're going to go right into the last piece where we're going to do some completing the square to find the equation of our ellipse. And we're going to write it in the form of x minus h squared over whatever plus y minus k squared over whatever. I don't want to put the a squared or the b squared because it's going to depend on where that number is, what the a and the b are going to be. So just know that there will be some denominators here. All right, so completing the square on these. We will definitely do a lot of practice with this in class, but I will model one of these with you. So when we look at this, we're going to get our x's together first. So we're going to have 4x squared minus 32x, leave some space, okay? Then we're going to take the 9y squared plus 36y, leave some space. And this constant of 64, we're going to move it to the other side, so it'll be minus 64. Okay, this is how we start. And then, because we want to ultimately be able to factor these so that these are just x and y something squareds, we need to factor out whatever's in front of the x squared and y squareds. So in this first one, I'm going to factor out the 4, which leaves me with x squared minus 8x. And we're going to complete the square in a moment. Then there's plus sign, and we factor out the 9 here, so that gives us y squared plus 4y blank. And we're going to have a couple of blanks to fill over here. We're going to complete the square. Let me use a different color here. So negative 8, split that in half. Negative 8 divided by 2 is negative 4, but then square that, you get 16. And then here we take 4, this 4 right here, divide it by 2, and then square it. So 4 divided by 2 is 2, and then square it gives us 4. Now, I would just say, okay, put the 16 and the 4 over to the other side, but remember we factored out some numbers. So 4 times 16 is 64. So that needs to come over here, okay? And then this 9 times 4 is 36, so I need to make sure that I do 36 here. All right? And don't worry, we'll practice this more, but that's how we're getting those numbers that I put over to the right. And now what we're going to do is we're going to finish this off by factoring and then solving it out. Let's see, we know this is a perfect square, so it'll be x minus, so when I divided the 8 by 2, that's my 4. That's what that part would be. Then I have my 9. Y plus 2, because the 4 divided by 2 is my 2 squared. On the right side, negative 64 and positive 64 cancel, so I just have 36. And we're almost home. So now we have to divide everything by 36. And I'm probably not going to have time to do this one anyway, so I'll just put the right answer over here. 436 simplifies to 1/9. So it'll be x minus 4 squared over 9. 936 simplifies to 1/4, so it'll be y plus 2 squared over 4 equals 1. And once you have it in that form, you would be able to identify the center. You could then be able to take a graph to it, and all will be good. But don't worry, we will practice more in class, okay? So do not worry about that. All right, so when you fill that part out on your Pear Deck, I know you're going to ask me to do more of these. We will definitely do more of these, so don't worry.